Okay, here's an example of using Sage Math, to go after the rank and nullity of a matrix, get the basis vectors for the column space, the row space, and even the null space. It's not real automated, but at any rate, I'll do a couple of these. So first, the example that I did in just introducing this idea of rank, nullity, and the basis vectors for the different spaces. Let's see. So here's the matrix. 1, -1, 3, 2, 3, -2, 3, 2, 1. And so I put that into Sage, and then I show it just to make sure it's correct. Then I get the rank and nullity and so forth. So here I've added some just nice stuff. You know, the rank of A equals, I put that in double quotes. That's text that it will print out. Then comma, and then I told it A, and then dot rank. Okay, so that's all I have to do to get the rank of A is A dot rank. And similarly for the nullity, you know, so then I put a comma in another text box here of the nullity, and then A dot nullity, and then I show that the sum sums up to the number of columns here. So itchy nose about to sneeze, I think. But anyway, so we can get those. And then if we want to get the basis, we need to do a reduced row echelon form. So then I say, well, let's let B be the reduced row echelon form of A, and then I show what that is. And then notice here I say after looking at B is when I come up with all this stuff. So, you know, if I hit evaluate and I come down here, there's A. The rank was 2, and we see that here with the 2 leading columns or the 2 non-zero rows. The nullity then is 1. We had that column for our nullity, or the null space, and when we add those two we get 3, which is the number of columns here. And so, you know, I can read off of this and see that, okay, you know, as we saw in the other video, I can take this first vector 1, 2, 3 and this vector -1, 3, 2 as the basis for my column space, and I can take this row here of the B matrix, or the reduced row echelon form, 1, 0, 7/5 and 0, 1, -8/5 as my basis for my row space. Okay, so I do that up here. Now, you know, how did I know how to do that? The matrix from columns and so forth. Well, again, you know, if I'm on our linear algebra stuff and I go here to the Sage quick reference, that pulls this up, and this is kind of small, but if I make it a little bigger, you know, I looked over here at pieces of matrices, and you know, I found this matrix from columns, matrix from rows and columns. I didn't try that. Now, I tried the column first, or maybe I even tried columns. Yeah, columns down here. I tried that, but it doesn't make a matrix, and so that was a little bit of a problem. And you know, I saw the matrix from columns and rows, and so I ended up using that. So for the column space, I needed, you know, these first 2 columns of matrix A. And so that's what I do, is I take the first 2 columns. But remember, the indices start with 0, so I had to say matrix A dot matrix from columns 0 and 1, okay, because those would be the first two columns. And then I said show that, and there's the basis, 1 2 3 negative 1 3 2. It just took those first two columns here, but it's not totally automated. I had to look at this answer for the reduced row echelon form first before I knew what to tell it. And it would be a lot more complicated, I think, to figure out which columns I needed without looking, so to speak. But we can get the basis, and so I did that. So there's the column space and and its basis. And so after looking at B, I just took the rows, these non-zero rows, the 1 0 7 fifths. So I did the matrix from rows, and again it was the first two rows, so I took 0 1. Now it will be the case that the rows, if I could do the rows just fine, actually, because all I really need to know is the rank. So I could set something up where I would be able to tell it to get as many rows as was the rank. I know how to do that. Again, we don't need to. We're looking at it anyway, so I can just look at it and see that I need the first two rows. Now here, I tossed in a transpose to get these as column vectors then. So yeah, you don't have to. I mean, that may just piss you off to do that, and so all you have to do is remove that transpose, dot transpose, if you want them to stay as rows. But I did them as columns, and so when I did that basis for the row space, you see 1 0 7 fifths as a row became the column 1 0 7 fifths and 0 1 negative 8 fifths. So there's my basis for the row space. And then here's the hard part, because if you try to even sort of automate it, which is what I sort of did, I tried to get it to print it out nicely. Okay, well, we need the negative of this non-leading column, and so that part was pretty easy. I knew which column I needed. It was the third one, but again, indices start at 0, so I needed to put a 2 in there. So matrix from columns and just column 2. And but I also know that they move to the other side of the equal sign when you're doing that, and so I needed the negative on those. So I made it a negative B from those. So that's all fine. But the thing is, you need to substitute a 1 for that indeterminate variable or arbitrary variable, x, in this case x3, right? This 0 down here needs to be a 1 to form the actual basis. Okay, and so I needed to change that 0 to a 1. Well, I knew which row it was. It was the last row, so that would be a row 2 again. Now this is a matrix, so I had to tell it which column. Now it only had one column, right? There's only one column there, but you still have to tell it. So I had to say 2 0, so the first column is column 0. And I just assigned it a 1, so I substituted a 1 for that 0, and then I showed it, and I did it right. I got it correct. Now that looks fine, except this is going to be, if you don't have a square matrix, if I have more columns than rows, then actually this part, substituting the 1s, might get kind of nasty. And so, you or me, either one of us, might be better off, just going from here and taking care of it as we need to. But I'll do a video with a non-square matrix to kind of show what the issue is here with that non-square matrix, trying to set this up and get it to print out a nice set of vectors for a basis. Okay, but therefore, definitely for a square matrix or even a rectangular matrix, where you are not going to try to get it to show the null space vectors, you'll just do it by hand. This is pretty straightforward, really, right? If you did everything by hand, all you really need to do is get that reduced row echelon form and then show it, because once I do that and I've got the original matrix here, I can get my column space from matching up the columns down here with the columns there. I can get my row space simply by taking the rows of the reduced row echelon form, and I can get my null space through a little more work, but again, I pretty much see it from my non-leading columns. And just using the reduced row echelon form utility, and kind of checking things with the rank and the nullity and summing the two and so forth, just checking that is really nice use of the technology. And so that is one example of using SageMath to help me out on getting getting the rank and nullity, and then getting bases for the different spaces.